Hello and welcome back. This will be the fourth video in the Essential Google Cloud Infrastructure Core Services. Today I already did another video. I will start doubling my effort. As we have seen, I haven't been promoted to the Diamond League, and this means I need to put more effort, a bit more time each day. So today, for example, I would like to finish this course about the core services. Let's see if I can do it. So the
In this
last
module, we
module
will
we
cover
completed, we had a lab about storage services. Now we have resource management and resource monitoring. Let's go. Let's deep in this.
In this module, we will cover resource management. Resources in GCP are billable,
Put a
so managing
higher
them means
speed.
controlling cost. There are several methods in place for controlling access to the resources, and there are quotas that limit consumption. In most cases, the default quotas can be raised on request, but having them in place provides a checkpoint or a chance to make sure that this really is a resource you intend to consume in greater quantity. In this module, we will build on what we learned in the Cloud IAM module. First, I will provide an overview of the resource manager. Then, we will go into quotas, labels, and names. Next, we will cover billing to help you set budgets and alerts. To complete your learning experience, you will get to examine
This
billing
is
data with BigQuery
just
in a
an
lab.
index of the
Let's get started with an overview of Resource Manager.
Let's go.
The Resource Manager lets you hierarchically manage resources by project, folder, and organization. This should sound familiar because we covered it in the Cloud IAM module. Let me refresh your memory. Policies contain a set of roles and members, and policies are set on resources. These resources inherit policies from their parent, as we can see on the left. Therefore, resource policies are a union of parent and resource, if an IAM allow policy is associated. However, if an IAM deny policy is associated with the resource, then the policy can prevent certain principals from using certain permissions, regardless of the roles they're granted.
Although IAM policies are inherited top to bottom, billing is accumulated from the bottom up, as we can see on the right. Resource consumption is measured in quantities like rate of use or time, number of items, or feature use. Because a resource belongs to only one project, a project accumulates the consumption of all its resources. Each project is associated with one billing account, which means that an organization contains all billing accounts. Let's explore organizations, projects, and resources more. Just to reiterate, an organization node is the root node for all Google Cloud Platform resources. This diagram shows an example where we have an individual, Bob, who has control of the organizational domain through the organization admin role. Bob has delegated privileges and access to the individual projects to Alice by making her a project creator. Because a project accumulates the consumption of all its resources, it can be used to track resources and quota usage. Specifically, projects let you enable billing, manage permissions and credentials, and enable service and APIs. To interact with Cloud Platform resources, you must provide the identifying project information for every request. A project can be identified by the project name, which is a human-readable way to identify your projects, but it isn't used by any Google APIs. There is also the project number, which is automatically generated by the server and assigned to your project. And there is the project ID, which is a unique ID that is generated from your project name. You can find these three identifying attributes on the dashboard of your GCP console.
Now that we know that a
Here we
project
have
accumulates
a
the consumption of
module,
all of its resources,
a
let's talk about
chapter
quotas.
about quotas.
All resources in Google Cloud are subject to project quotas or limits. These typically fall into one of the three categories shown here. 1. How many resources can a project create? For example, you can only have 15 VPC networks per project. 2. How quickly can you make API requests in a project or rate limits? For example, by default, you can only make 5 administrative actions per second per project when using the Cloud Spanner API. And 3. Regional quotas. For example, by default, you can only have 24 CPUs per region. Given these quotas, you may be wondering, how do I spin up one of those 96 core VMs? As your use of Google Cloud expands over time, your quotas may increase accordingly. If you expect a notable upcoming increase in usage, you can proactively request quota adjustments from the quotas page in the Cloud Console. This page will also display your current quotas. If quotas can be changed, why do they exist? Project quotas prevent runaway consumption in the case of error or malicious attack. For example, imagine you accidentally create 100 instead of 10 compute engine instances using the G-Cloud command line. Quotas also prevent billing spikes or surprises.
Projects and folders provide levels of segregation for resources, but what if you want more granularity? That's where labels come in. Labels are a utility for organizing GCP resources. Labels are key value pairs that you can attach to your resources, like VMs, disks, snapshots, and images. You can create and manage labels using the GCP console, cloud, or the Resource Manager API, and each resource can have up to 64 labels. For example,
do we actually have a service called Resource Manager, or is it just a concept? Oh yeah, and I already visited its page. Okay, but let me see, GCP, let's go to our cloud platform. Oh shit, why it's in fucking Spanish? I have no projects. Fuck then. How do I change the language here? Oh my god. What the fuck, Latin America? Okay, so resource manager. Oh, but yeah, it's just, wait. Why? I give panel why? So here we have also manage resources. Okay, create project, create folder, resource pending deletion. So if I create a project, imagine then I can assign roles on that resource. Okay. Well, never used this page. I've been always working as a cloud engineer, never organizing these aspects. So that's my ignorance.
Example, you could create a label to define the environment of your virtual machines. Then you define the label for each of your instances as either production or test. Using this label, you could search and list all your production resources for inventory purposes. Labels can also be used in scripts to help analyze costs or to run bulk operations on multiple resources. The screenshot on the right shows an example of 4 labels that are created on an instance. Let's go over some examples of what to use labels for. I recommend adding labels based on team or cost center to distinguish instances owned by different teams. You can use this type of label for cost accounting or budgeting. For example, team marketing and team research. You can also use labels to distinguish components. For example, component Redis, component frontend. Again, you can label based on environment or stage. You should also consider using labels to define an owner or a primary contact for a resource. For example, owner, Gaurav, contact Adam. Or add labels to your resources to define their state. For example, state in use, state ready for deletion. Now, it's important to not confuse labels with network tags. Labels, we just learned, are user-defined strings in key value format that are used to organize resources, and they can propagate through billing. Network tags, on the other hand, are user-defined strings that are applied to instances only and are mainly used for networking, such as applying firewall rules and custom static routes. For more information about using labels, see the links in the course resources.
Okay.
Because the consumption of all resources under a project accumulates into one billing account, let's talk billing. To help with project planning and controlling costs, you can set a budget. Setting a budget lets you track how your spend is growing toward that amount. This screenshot shows the budget creation interface. First, you set a budget name and specify which project this budget applies to. Then you can set the budget at a specific amount or match it to the previous month's spend. After you determine your budget amount, you can set the budget alerts. These alerts send emails to billing admins after spend exceeds a percent of the budget or a specified amount. In our case, it would send an email when spending reaches 50%, 90%, and 100% of the budget amount. You can even choose to send an alert when the spend is forecasted to exceed the percent of the budget amount by the end of the budget period. In addition to receiving an email, you can use pub sub notifications to programmatically receive spend updates about this budget. You could even create a cloud function that listens to the pub sub topic to automate cost management. Here is an example of an email notification. The email contains the project name, the percent of the budget that was exceeded, and the budget amount. Another way to help optimize your Google Cloud spend is to use labels. For example, you could label VM instances that are spread across different regions. Maybe these instances are sending most of the traffic to a different continent, which could incur higher costs. In that case, you might consider relocating some of those instances or using a caching service like Cloud CDN to cache content closer to your users, which reduces your networking spend. I recommend labeling all your resources and exporting your billing data to BigQuery to analyze your spend. BigQuery is Google's scalable, fully managed enterprise data warehouse with SQL and fast response times. Creating a query is as simple as shown in this screenshot, which you will explore in the upcoming lab.
In the upcoming lab, you will examine billing data that we exported for you. Let me show you how to export billing data and demonstrate other common activities that a billing administrator performs. These actions cannot be performed in the Quick Labs environment because of security restrictions. Therefore, I'm going to walk you through them as a demo. So here I am in the GCP console, and what I want to do is navigate to billing. So I'm going to click on the navigation menu and click on billing. So here I'm provided with an overview. I'm actually using a trial account, as you can see, but the same concepts apply to any account. We can see the consumption for the current month. In my case, I have some promotional credits here. If I had multiple billing accounts, then you'd be able to choose from them right up here. Again, credits, billing account also has a name. If you go to payment overview, you'll can see the payment method that is currently selected. Now, the other really big thing we can do here is set up budgets and alerts. So if I click on that and then click on create a budget, I first just give it a name, say my budget alert. I can select the specific projects that I want these alerts on. It could just be one, it could be several. Click next, then the type. So I either specify an exact dollar amount, or I start with my last month's spend. So if last month I spent, let's say, a certain dollar amount, it would pull that dollar amount directly in there. In our case, let's say we want to target an amount of $500. It's also including credits in this cost. You could disable that. and then we define the thresholds for the alerts. So by default, it sets up this 50, 90 to 100%, and the dollar amounts are just being pulled from the 500 that I just plugged in there earlier. You can also choose between actual and forecasted, and you can read a little bit more what this forecasted is about here. We could remove these. So let's say maybe we wanted to add an earliest threshold already at 25%. Then we could do that. We could even go further and actually connect to a Cloud Pub subtopic and then do all sorts of automation as we discussed in the slides. So then from here, I can just click finish, and it's then going to be sending me emails around this. I can also see sort of a menu here that shows how far I've gone in this spend. And so I can come in here at any moment and also see, am I close to that 25% mark already? Then the other thing that's pretty interesting on this page is the transaction page. So this will show all of the different charges. Again, I have a credit in here, so every charge is being offset by.
Let's examine billing data with BigQuery. In this lab, you will sign into BigQuery and create a dataset. In this dataset, you will create a table by importing billing data that is stored in a cloud storage bucket. Next, you will run simple queries on the imported data, and then you will run more complex queries on a large.
Okay, let's start this lab. It will be a quick one, I imagine. It's an introductory, 5 credits, suppose 1 hour. But I think it will take just 15 minutes. So, okay, we already have this. Okay, let's go here. Task 1, sign into BigQuery and create a data set. Click on View Action icon next to your project ID and click Create Dataset. Okay, so BigQuery. Done. Create Dataset. Billing Dataset. Data location US. Default maximum table age 1 days. Click Create Dataset. You should see billing dataset in the left pane. Create a table and import. Click View Actions icon next to billing dataset. Create table. For source, specify the following and leave the remaining settings as the default. So create table, create from Google Cloud Storage, select file GGS bucket. So we have another file. Destination, sample info table, and type table native. Okay, create table. Okay, examine table. So click sample info table. Click details, you can see number of rows. Number of rows, okay. Compose a simple query. When you reference a table in a query, both the data set and the table ID must be specified. The project ID is optional. In the project ID is not, if the project ID is not specified, the query will default to the current project. All the information you need is the column on the left, you see the data set, the table ID. Recall that clicking on table name discovered all the field name. Now construct. So we're based on the cost field. Okay. Click compose new query, press in the following. Okay. Click run. What I have here, how many rows had cost greater than 0? 70 and something, yeah. Okay. Task 4, analyze a large billing dataset with SQL for new query paste the following in query editor. So SQL query, billing account ID, project service description, currency, cost, usage amount, billing assets. Okay. So we select all these columns from this table. We have this number of lines. To find the latest 100 record where there were charges for new waste. Okay. To find all charges that were more than $10 for a query paste. Well, we're just running queries in this lab. I mean, kind of boring. Find product with the most reference billing data from the query quest. Okay, which product had the most billing records? Compute engine. Find the most frequently used product costing more than $1 for new query. Cloud storage. Find the most commonly charged unit of measure. What the fuck? Man, this lab is completely. Yeah, I mean. To find product with a high aggregate cost. I mean, it's kind of useful to know that we have all these canned queries, but kind of boring just to go through all of them. Okay, and lab, we needed 9 minutes to complete it. So we learned that we can select and perform all these queries really easily, just having the data imported in a table and then just putting simple conditions in our query. And then we can also order limit all the normal SQL operations. Yeah, just okay. So we ended this activity. Now let's go to the next one.
In this lab, you imported billing data into BigQuery that had been exported as a CSV file. You first ran a simple, and you can see my data set is created, and I should see it right here. There it is. So now I'm going to create a table in that data set. Create a table for the.
Okay. so what happens now is that we finish this module in just 20 minutes. No resource in Google Cloud can be used without being associated with a project. Budget is set at 500 and alert is set at 100%. What happens when the full amount is used? Nothing. There is no point in sending it here when there is no point. So my budget is 500 and an alert is set at 100%. How do quotas protect Google Cloud customers? Okay, next.
In this module, we covered the Cloud Resource Manager and went into quotas, labels.
In this module, I'll give you an overview of the resource monitoring options in Google Cloud. The features covered in this module rely on Google Cloud's Operations Suite, a service that provides monitoring, logging, and diagnostics for your applications. In this module, we're going to explore the cloud monitoring. Google Cloud's Operations Suite dynamically discovers cloud resources and application services based on deep integration with Google Cloud and Amazon Web Services. Because of its smart defaults, you can have core visibility into your cloud platform in minutes. This provides you with access to powerful data and analytics tools, plus collaboration with many different third-party software providers. As mentioned earlier, Google Cloud's Operations Suite has services for monitoring, logging, error reporting, and fault tracing. You only pay for what you use, and there are free usage allotments so that you can get started with no upfront fees or commitments. For more information about pricing, refer to the link in the course resources. Now, in most other environments, these services are handled by completely different packages or by a loosely integrated collection of software. When you see these functions working together in a single, comprehensive, and integrated service, you'll realize how important that is to creating reliable, stable, and maintainable applications.
Now that you understand Google Cloud's Operations Suite from a high-level perspective, let's look at cloud monitoring. Monitoring is important to Google because it is at the base of site reliability engineering, the discipline that applies aspects of software engineering to operations whose goals are to create ultra-scalable and highly reliable software systems. This discipline has enabled Google to build, deploy, monitor, and maintain some of the largest software systems in the world. Cloud monitoring dynamically configures monitoring after resources are deployed and has intelligent defaults that allow you to easily create charts for basic monitoring activities. This allows you to monitor your platform, system, and application metrics by ingesting data, such as metrics, events, and metadata. You can then generate insights from this data through dashboards, charts, and alerts. For example, you can configure and measure uptime and health checks that send alerts via email. A metric scope is the root entity that holds monitoring and configuration information in cloud monitoring. Each metric scope can have between 1 and 375 monitored projects. Now, monitoring data for all projects in that scope will be visible. A metric scope contains the custom dashboards, alerting policies, uptime checks, notification channels, and group definitions that you use with your monitored projects. A metric scope can access metric data from its monitored projects, but the metrics data and log entries remain in the individual projects. The first monitored Google Cloud project in a metric scope is called the scoping project, and it must be specified when you create the metric scope. The name of that project becomes the name of your metric scope. To access an AWS account, you must configure a project in Google Cloud to hold the AWS connector. Because metric scopes can monitor all your Google Cloud projects in a single place, a metric scope is a single pane of glass through which you can view resources from multiple Google Cloud projects and AWS accounts. All users of Google Cloud's Operations Suite with access to that metric scope have access to all data by default. This means that a role assigned to one person on one project applies equally to all projects monitored by that metric scope. In order to give people different roles per project and to control visibility to data, consider placing the monitoring of those projects in separate metric scopes. Cloud monitoring allows you to create custom dashboards that contain charts of the metrics that you want to monitor. For example, you can create charts that display your instance's CPU utilization, the packets or bytes sent and received by those instances, and the packets or bytes dropped by the firewall of those instances. In other words, charts provide visibility into the utilization and network traffic of your VM instances, as shown on this slide. These charts can be customized with filters to remove noise, groups to reduce the number of time series, and aggregates to group multiple time series together. For a full list of supported metrics, please refer to the documentation. Now, although charts are extremely useful, they can only provide insight while someone is looking at them. But what if your server goes down in the middle of the night or over the weekend? Do you expect someone to always look at dashboards to determine whether your servers are available or have enough capacity or bandwidth? If not, you want to create alerting policies that notify you when specific conditions are met. For example, as shown on this slide, you can create an alerting policy when the network egress of your VM instance goes above a certain threshold for a specific time frame. When this condition is met, you or someone else can be automatically notified through email, SMS, or other channels in order to troubleshoot this issue. You can also create an alerting policy that monitors your usage of Google Cloud's Operations Suite and alerts you when you approach the threshold for billing. For more information about this, please refer to the documentation. Here is an example of what creating an alerting policy looks like. On the left, you can see an HTTP check condition on the Summer01 instance. This will send an email that is customized with the content of the documentation section on the right. Let's discuss some best practices when creating alerts. We recommend alerting on symptoms and not necessarily causes. For example, you want to monitor failing queries of a database and then identify whether the database is down. Next, make sure that you are using multiple notification channels like email and SMS. This helps avoid a single point of failure in your alerting strategy. We also recommend customizing your alerts to the audience's needs by describing what actions need to be taken or what resources need to be examined. Finally, avoid noise because this will cause alerts to be dismissed over time. Specifically, adjust monitoring alerts so that they are actionable and don't just set up alerts on everything possible. Uptime checks can be configured to test the availability of your public services from locations around the world, as you can see on this slide. The type of uptime check can be set to HTTP, HTTPS, or TCP. The resource to be checked can be an App Engine application, a Compute Engine instance, a URL of a host, or an AWS instance or load balancer. For each uptime check, you can create an alerting policy and view the latency of each global location. Here is an example of an HTTP uptime check. The resource is checked every minute with a 10-second timeout. Uptime checks that do not get a response within this timeout period are considered failures. So far, there is a 100% uptime with no outages. Monitoring data can originate at a number of different sources. With Google Compute Engine instances, because the VMs are running on Google hardware, the hypervisor cannot access some of the internal metrics inside of VM, for example, memory usage. The Ops agent collects metrics inside the VM, not at the hypervisor level. The Ops agent is the primary agent for collecting telemetry data from your Compute Engine instances. This diagram shows how data is collected to monitor workloads running on a Compute Engine instance. Ops agent installed on the Compute Engine collects data beyond the system metrics. The collected metric is then used by cloud monitoring to create dashboards, alerts, uptime checks, and notifications to drive observability for workloads running in your application. You can configure the Ops agent to monitor many third-party applications. For a detailed list, refer to the documentation. The Ops agent supports most major operating systems such as CentOS, Ubuntu, and Windows. If the standard metrics provided by cloud monitoring do not fit your needs, you can create custom metrics. For example, imagine a game server that has a capacity of 50 users. What metric indicator might you use to trigger scaling events? From an infrastructure perspective, you might consider using CPU load or perhaps network traffic load as values that are somewhat correlated with the number of users. But with a custom metric, you could actually pass the current number of users directly from your application into cloud monitoring. To get started with creating custom metrics, please refer to the documentation. When you want to maintain a metric at a target value, specify a utilization target. The autoscaler creates VMs when the metric value is above the target and deletes VMs when the metric value is below the target. If the metric comes from each VM in your managed instance group, then the autoscaler takes the average metric value across all VMs in the managed instance group and compares it with the utilization target. If the metric applies to the whole managed instance group and does not come from the VMs in your managed instance group, then the autoscaler compares the metric value with the utilization target. When your metric has multiple values, apply a filter to autoscale using an individual value from the metric.
Let's take some of the monitoring concepts that we just discussed and apply them in a lab. In this lab, you will learn how to use Stackdriver monitoring to gain insight into applications that run on GCP. Specifically, you will enable Stackdriver monitoring, add charts to dashboards, and create alerts, resource groups, and uptime checks.
Let's go. Okay, we already have everything set up for this lab. Task 1, create a cloud monitoring workspace. Verify resources to monitor. 3 VM instances have been created for you that you will monitor. Create Compute Engine VM instances. Notice various ng stack instances. Create a monitoring workspace. Then click monitoring products and page section. Okay. Wait for your workspace to be provisioned. The monitoring dashboard opens, your workspace is ready. Monitor is important to ensure Google complies with Google use to ensure that they all have metrics to and interesting bodies. Reports requires population reporting. What? Fuck me. Oh, this is a multiple choice. Fuck you. Oh, Can you believe this? Just selected this before. Fuck you. Okay, so I have my dashboard about my KPIs. Okay. Create a dashboard. Dashboards, create dashboard. Type my dashboard. Dashboard. So add a chart, add widget, select line for a widget that you can give your chart a name. You can advise this before you set it. So should make type CPU utilization or CPU usage metric file drop down. Okay. And widget line. Which title? CPU usage utilization. Click VM instance, select CPU, and click. Okay, note uncheck active if you're unable to find the CPU utilization. Click add filter and explore the various options. Last name, that one. Okay, apply to create a chart, metric explorer. You are to try to create a chart to just create using the metrics explorer. Okay, so apply metric explorer, select the metric. Okay. Save chart. Okay. Check my progress. Alerting policies. What is not recommended best practice for alerts? Report all noise to ensure the points are presented. Create an alert and add the first condition. So alerting of create policy. Select the metric to launch. Type VM instance in filter versus metric and click VM instance. CPU usage. You can look at the VM resource tab you might have. Set rolling windows to 1 minute. Where is this? Click next, see threshold position to show and set 20 as your threshold value. Alert condition. Repeat the step of click next. Repeat the condition for a different instance. Click next. Motivation to reset all conditions are met. Click next. Add new for email, manage for the display name. So my personal email is this. Click save. Where do I click save? I just click saved. Back, configure notification, final alert. Okay, so what? Tab. Click on notification channels again. To get display information, clicking okay, yeah. Display name and click OK. Okay, click next review. Okay. Fuck. Review alert. Oh my god. Did I create the alert? Oh, it was here. What the fuck? Wait, it was in the center. Okay, resource groups. Last pane groups, create group. VM instances. Jigs. let's say group, create group. So type in Jinx in value. In criteria section, type nginx in the value field below. Click done. Click create. What the fuck? Okay, but if I go to dashboards, my dashboard. Oh, if I go to dashboard, I have this. So create. Oh, what the fuck, man? Groups. We have instances. Type in JSON. I got update monitoring. Select all valid targets for cloud monitoring uptime alert notifications. Email, SMS, PubSub, I'm sure, and third-party services. There's at least one more correct answer. What the fuck is a webhook in this case? It's just a trigger, imagine. In the monitoring tab, you click on uptime checks. Create uptime check. So say following and leave the settings that defaults. Okay, HTTP instance group. Check frequency 1 minute. Click on continue to leave an alert. Okay. Select your rotation chance from the drop down. PP, okay. Click continue for title and name for just a check. When New screen check whenever connect. Create. Disable the alert, navigate to alert section, click all alert policies on your policy detail page, click on enable toggle on top of the page. What? Cannot see it. So yeah, I was expecting just one big toggle. Okay. Therefore, we are ending this lab now. Okay, submit. Went to the project at charts. Okay, it was interesting. However, yeah, kind of boring anyway. Repetitive tasks, which are okay to know where they are.
In this lab, you
but
got an
yeah,
overview of stack driver
it's
monitoring.
not
You learned
the
how to monitor your
core
project,
really
create
for
alerts with
me.
multiple conditions, add charts to dashboards, create resource dashboard, create some
Here
groups.
we're having the
P
same
is to check an instance.
things we
It
just
applies to
have
a
done.
group, and I'm going to select the group I created, which is VM instances, and I'm going to check.
Logging.
Monitoring is the basis of Google Cloud's Operations Suite, but the service also provides logging, error reporting, and tracing. Let's learn about logging. Cloud logging
Logging was my daily bread while working as a cloud engineer. Everything has to be inspected, and Log Explorer was my hope for everything.
allows you to store, search, analyze,
Of course, when people enabled logs for their services.
monitor, and alert on log data and events from Google Cloud and AWS. It is a fully managed service that performs at scale and can ingest application and system log data from thousands of VMs. Logging includes storage for logs, a user interface called Logs Explorer, and an API to manage logs programmatically. The service lets you read and write log entries, search and filter your logs, and create log-based metrics. Logs are only retained for 30 days, but you can export your logs to cloud storage buckets, BigQuery datasets, and pub subtopics. Exporting logs to cloud storage makes sense for storing logs for more than 30 days. But why should you export to BigQuery or PubSub? Exporting logs to BigQuery allows you to analyze logs and even visualize them in Looker Studio. BigQuery runs extremely fast SQL queries on gigabytes to petabytes of data. This allows you to analyze logs such as your network traffic so that you can better understand traffic growth to forecast capacity, network usage.
Ah, quieren código. Let's go. Okay, so I received the package. Okay, back to action.
To optimize
Let's
network traffic
finish
expenses
this.
or network forensics to analyze incidents. For example, in this screenshot, I queried my logs to identify the top IP addresses that have exchanged traffic with my web server. Depending on where these IP addresses are and who they belong to, I could relocate part of my infrastructure to save on networking costs or deny some of these IP addresses if I don't want them to access my web server. If you want to visualize your logs, I recommend connecting your BigQuery tables to Looker Studio. Looker Studio transforms your raw data into the metrics and dimensions that you can use to create easy-to-understand reports and dashboards. I mentioned that you can also export logs to PubSub. This enables you to stream logs to applications or endpoints. Let's learn about another feature of Google Cloud's Operations Suite, error reporting. Error reporting counts, analyzes, and aggregates the errors in your running cloud services. A centralized error management interface displays the result with sorting and filtering capabilities, and you can even set up real-time notifications when new errors are detected. Currently, error reporting is generally available for App Engine on both standard and flexible environments. App Scripts, Compute Engine, Cloud Functions, Cloud Run, Google Kubernetes Engine, and Amazon EC2. In terms of programming languages, the exception stack trace parser is able to process Go, Java, .NET, Node.js, PHP, Python, and Ruby.
Okay.
Tracing is another Stackdriver feature integrated into GCP.
CloudTrace is a distributed tracing system that collects latency data from your applications and displays it in the Google Cloud Console. You can track how requests propagate through your application and receive detailed near real-time performance insights. CloudTrace automatically analyzes all of your application's traces to generate in-depth latency reports that surface performance degradation and can capture traces from App Engine, HTTPS load balances, and application instrumented with the CloudTrace API. Managing the amount of time it takes for your application to handle incoming requests and perform operations is an important part of managing overall application performance.
Okay, profiling.
Finally, let's cover the last feature of Google Cloud's Operations Suite in this module, which is the profiler. Poorly performing code increases the latency and the cost of applications and web services every day. Cloud Profiler continuously analyzes the performance of CPU or memory-intensive functions executed across an application. While it's possible to measure code performance in development environments, the results generally don't map well to what's happening in production. Many production profiling techniques either slow down code execution or can only inspect a small subset of a code base. Profiler uses statistical techniques and extremely low-impact instrumentation that runs across all production application instances to provide a complete picture of an application's performance without slowing it down. Profiler allows developers to analyze applications running anywhere, including Google Cloud, other cloud platforms, or on-premise with support for Java, Go, Node.js, and Python.
Great.
Google Cloud's Operations Suite also supports a rich and growing ecosystem of technology partners, as shown on this slide. This helps expand the ADOps, security, and compliance capabilities available to Google Cloud customers. The diagram shows the architecture of how Benplane ingests logs and then how those logs are ingested into Cloud Logging plus collects metrics and then how these metrics are ingested into Cloud Monitoring. Adding Blue Medora's software, Benplane, helps collect the metrics and logs and push them into the open APIs that form our core observability platform. Once a log source is ingested into Cloud Logging, you can view and search through the raw log data and create metrics off of those log files, just like logs collected from Google Cloud. You can use all the features of Google Cloud's Operations Management Suite, including viewing logs in real time in the Google Cloud Console or through log-based metrics to view logs and metrics side by side and alert on logs. This diagram depicts the architecture involved in filtering and exporting log data from Cloud Logging and alert on logs. This time in the Google Cloud Console or through log-based metrics to view logs and metrics side by side and alert on logs. This diagram depicts the architecture involved in filtering and exporting log data from Cloud Logging to Splunk Enterprise. PubSub is used to temporarily store logged messages as they are published from Cloud Logging before delivering them to Splunk. Cloud Logging begins by gathering logs into a centralized location, then forwards them to Google Cloud's PubSub messaging service. PubSub manages the log data using a dedicated channel. A primary data flow pipeline extracts logs from PubSub and delivers them to Splunk for analysis. To safeguard against errors, a secondary data flow pipeline runs in parallel, capable of resending logs if delivery fails. Finally, Splunk, deployed on-premises in Google Cloud as SaaS or via a hybrid approach, receives the logs and enables in-depth analysis. The workflow uses a streaming pipeline to natively push your Google Cloud data to your Splunk Cloud or Splunk Enterprise instance using the PubSub to Splunk Dataflow template. Using this Dataflow template, you can export data from PubSub
really
to Splunk.
Looking to something really specific now, which I don't know, I don't understand, that I need to study more. What is the foundational process at the base of Google site reliability engineering? What the fuck I know? Did they mention this? What is the foundational process at base of Google site reliability? Well, I think they mention it here.
Now that you understand Google
right?
Cloud's Operations Suite, it is at the base of site reliability engineering, the discipline that applies aspects of software. Now that you understand Google Cloud's Operations Suite from a high-level perspective, let's look at cloud monitoring. Monitoring is important to Google because it is at the base of site reliability engineering, the discipline that applies.
Okay, so it's monitoring. Okay, monitoring. What is the purpose of cloud trace service? Latency. Google Cloud's Operations Suite integrates several technologies, including monitoring, logging, error, and debugging that are commonly implemented in other environments as separate solution using separate products. What are key benefits of integration of this? Better for cloud only source long general clouds. Ability to replace one tool with another. Oh, it's the last one. I will take it. And let's go.
In this module, I gave you an overview of Google Cloud's Operations Suite and its monitoring, logging, error reporting, fault tracing, and profiling features. Having all of these.
Thank you for taking the Essential Cloud Infrastructure Core Services course. I hope you have a better understanding of how to administer IAM, choose between the different data storage services in.
Oh, so let's download. No, I mean, that's nothing interesting inside here, so I will not download this file. Next. Yeah. Congratulations, you've completed. Okay, so like in 1 hour plus 1 hour from this morning, I completed 2 modules, which leads me to a complete course after 5 videos, no, 4 videos. Okay. Course complete. So the next course I will practice is this one, which is from the same series, and it's scaling and automation focused. So yeah, I will just start it in the next video. Let's have a look at the board here. Leaderboard, Gold League in 6 days. The first 10 will be promoted to the Diamond League. And look here. So we can't sleep really well. I will be flourishing cheetah for who wants to follow my race here. Select an avatar. Of course, I will select an avatar. Well, they're really strange. I mean, mobility. What the fuck? Okay. I'm pet owner. Well, Yeah, I will just select the pet owner. As you can see, I'm bald and I have a dog. Okay, so I will just close the video for now. See you in the next one where I will be doing the next course. Thank you for looking at this video.